The Cassini mission has been exploring the Saturn system for nearly 13 years and has rewritten the textbooks on the ringed planet and its moons. But the spacecraft is pretty much out of fuel. Following NASA's planetary protection guidelines, the mission will end with Cassini plunging into Saturn's atmosphere. But before that happens, scientists and engineers have planned an exciting grand finale that promises some of the most amazing science and images of the whole mission. So how are they going to pull this off? Well, it really is going to take a special kind of crazy engineering. I am here with Morgan. She's a scientist on the Cassini project. The grand finale, it's going to be 22 orbits, about 6 months. What do we hope to accomplish in that amount of time?
We hope to accomplish a lot of incredible science, things that we have never been able to do before with the Cassini mission. We're going to go screaming over the top of Saturn. We'll be able to study the hexagon of Saturn's North Pole in greater detail than ever before. We're going to go shooting between Saturn and its rings, threading the needle, which means we'll be able to taste the ring particles, be able to understand more about what those are made of. We'll also be able to taste the atmosphere of Saturn. We're also going to get a better idea of the interior structure, since we'll be getting closer to Saturn than we've ever been. And then this will all culminate in Cassini's final plunge into Saturn's atmosphere, taking data for as long as possible and transmitting that back to Earth. To be able to do this engineering, to thread that needle between Saturn and its rings, is really challenging. That requires something called astrodynamics.
Okay, so what is astrodynamics? It's a form of engineering, but when we think about engineering typically, we think about people who are using physics and technology to build stuff. Astrodynamicists are building flight paths that will take our spacecraft to where they need to go. Let's go talk to one of the engineers who's pivotal in the design of this flight path on the Cassini spacecraft. Okay, this is Brent. He's our astrodynamicist at JPL. Brent, what makes the grand finale particularly difficult and challenging?
The grand finale is a series of 22 orbits where the periapsis, or the closest point of the orbit, is actually in this gap between the upper atmosphere of Saturn and the innermost part of the main rings. What we've done is we've designed this trajectory such that, utilizing one last Titan gravity assist, we can jump the entire ring system and place the spacecraft orbit inside this very, very small gap that's only 2,000 kilometers wide.
This concept of gravity assist, I think a lot of people have heard of it, but maybe not completely understand it.
What it essentially means is you're harnessing the gravity of a body that's orbiting another body. For Cassini, Titan, a very massive moon, is orbiting Saturn. If Cassini is also orbiting Saturn, I can fly very close to Titan. Depending on if I fly in front of, or behind, or above, or below, I can use that gravity to bend my trajectory. We harness that power. It's our engine, it's our tour design engine. As soon as we do that last Titan flyby, Cassini's fate is sealed. It is going to impact Saturn no matter what.
So, some really amazing science before we take this final plunge into Saturn. And let's remember why we're doing that. Why are we flying the spacecraft into the planet? It's to protect the moons of Saturn. For example, Enceladus, this great moon that has an ocean underneath the surface, it might just be this cozy little place for microbes to live. Now, if you look at our spacecraft, we try to keep it as clean as possible, but there's a real chance that we're bringing microbes from Earth with us. There's no way to avoid it. We want the moon as pristine as possible for future missions to go exploring. So for everyone out there, follow the grand finale of Cassini and check back here for some more crazy engineering.